Welcome to the first video of this course. This is just an introductory video to various concepts in thermodynamics that will become important later on. So, let us begin with the definition of system. System is whatever you are observing. The region of space in observation is called system. System is important because you can apply equations to the same larger system, and then you can divide that system into two smaller systems and apply equations to these two and get even more variables that you will be able to solve. So definition of system is very important because later on we will be switching around or playing with our system quite a bit. We will see how we can apply the same equation to two different systems, obviously of the same bigger part, and still get the same solution. Surrounding. Surrounding is everything that is not the system. Everything that is not the system. Surrounding is also important because it enables us to solve concepts like entropy. So this term will become important at the very end of the course when we are learning about entropy. Next we have boundary. The separation between system or surrounding. An important thing to note is that it can be real, that is physically present, or imaginary, as in the case with several open systems. Now we have several types of systems as well. These are divided into closed, open, and isolated. For a closed system, there is only mass transfer. There is no mass transfer. But there is energy transfer. For an open system, we have mass transfer as well as energy transfer. And for an isolated system, we have neither mass transfer nor energy transfer. Open system is also called control volume, CV. Closed system is also called control mass, CM. The distinction between these two systems is very important because later on we will learn how to apply thermodynamic equations in the context of these equations, and you will also get your problems in the context of these systems. So you will have to distinguish when to apply which equation and how to modify that equation to suit the type of system that you are working with, right? However, this comes very later, so don't worry about it right now, as we do begin with very simple systems. Okay. Next we have properties of a system. Intensive, extensive. Intensive are those properties that do not depend on mass of system. Non-mass dependent. And extensive are those which depend on mass. I'm sure most of you already know this from JEE prep, but for people who have thermodynamics course later on, like in 1-2 like I did, these can be as a refresher. So, examples of intensive properties are like your pressure, your temperature, your density of system. And extensive properties have a lot of examples like specific enthalpy, specific internal energy, etc. Next, I should explain what is meant by a state of a system since we are studying properties. State of a system. A state is a set of properties that completely describes a system. This is important. So I will write it down. Set of properties. Apologies for my handwriting. I'm not used to writing in a landscape format. I also don't have the writing cover that comes on iPads because my iPad is so old that they stopped making the writing cover for it. Okay, now how many properties do you need to completely describe a system? What is the minimum number of properties? So, this is something called the state postulate, and it is as follows. You don't really need to understand these too much, just remember them, just keep them in the back of your head because these things are not that useful. It states that for a simple, please note the words simple, compressible system, we need two independent properties. Independent is the keyword here. Now, obviously, the question arises, what is a simple compressible system? So we will just write it in black here. A simple compressible system which is not under the effect of any magnetic, electric, or gravitational field. So that describes what a state of a system means. Now let us describe what is a process. Actually, before this, I think it would be wise to describe what is equilibrium, since process is what happens to the equilibrium, right? Equilibrium of a system. It also has a lot of types. So a system can be in thermal equilibrium with its surroundings. It can be in mechanical equilibrium, like when the piston is left free and it is not moving anywhere. That is an indicator of mechanical equilibrium. Thermal equilibrium is when there is no heat exchange occurring. Chemical equilibrium. This happens, chemical equilibrium, if you think about it, happens when you completely drain a battery, because after that there is no force left to drive electrons. So the battery reaches a state of chemical equilibrium, right? And there is a phase equilibrium. So thermal means same temp and no heat flow. Mechanical means same pressure, because remember the piston is not moving, right? We will actually draw a piston diagram over here. Mechanical means this piston is static. So that means this is also PATM and this is also PATM. And no mass flow. Chemical equilibrium means no chemical reaction. However, this is not that important for us because this is not a chemistry focused course. This is a thermodynamics course. And phase means it phase equilibrium can only happen obviously when there are two or more phases present, because how can only one phase be in equilibrium with itself? So phase equilibrium means mass of the two phases does not change. If you're worried about these notes and my handwriting, don't worry. I have fair notes that I will be sharing in the video description. Let us just title this Introduction. Okay, and now an interesting concept. If a system has all of these equilibria at once, then it is said to be in thermodynamic equilibrium. Let us just center this, so it looks nice. Okay, an important thing to note is that state of a system, watch out for these pink lines, right? Because these are random one-liners that I will drop that are quite important. In my notes as well, these pink lines are important. State of a system can only be described when it is in thermodynamic equilibrium. This is because it is very difficult to describe the state of a system at every point in a process. We will get to process right after this. But my point is, it must be at a particular state of thermodynamic equilibrium. Only then will you be able to write its properties. Again, all of this is not too important. It is more or less obligatory, except open system and closed system. All of this is not that important to know. Just keep it in the back of your head. This is just an introductory lecture. We will get to solving problems later on. So that finishes equilibrium of a system and definition of system. Let us now move on to process. You must have heard of processes like adiabatic and all that, and that will also come. Now let's just quickly define a process. So process is defined as change undergone by system from equilibrium and if we have a series of processes from one state to another, then we call that a path. Perhaps the most important keyword in the whole process subcategory is a quasi-static process. It is an extremely slow process. Such that all your intermediate points are in equilibrium, which is why we are able to describe a system at any point. So we will mainly be dealing with quasi-static processes because we are able to describe what is going on at system at any point. All intermediate points are in equilibrium. It is important to note that real processes are very fast and they are approximated to quasi-static processes for analysis. And I think I will also be including a different category. This is a miscellaneous category that might show up in your, quizzes or whatever. We will be discussing something called the manometer. So obviously you've heard of a manometer. It is a device that is used to measure pressure by how much a height of a liquid rises. So let me just draw a quick diagram. My drawing is terrible. but it doesn't matter because on paper it is fine. Right, here we have a manometer. This is H1, and let us take this to be H2. Now it is important that we be aware of, I think it was called the Archimedes principle, where the pressure in any liquid at same height is the same. So for example, the pressure at this point and the pressure at this point would be exactly the same because they are at the same level inside the liquid. They can be different liquids as well. That is the important thing here. So this liquid is heavy and it is mercury, because I think mercury is the heaviest element. I don't know. So rho Hg, density of mercury, and this liquid is lighter. This is rho water, or we also call it the rho L, rho of the liquid. This is 0.1, this is 0.2, and H2 is actually this much. The difference in the levels is H2, and this is 0.3. Right. Let us try to write the pressure equations, right? So we know that since A and 1 are at the same level, PA equals to P1. Also, P1 equals to P2 minus rho L G H1, because you are going up. So we know that pressure increases by rho G H when we go down, right, in the ocean. So if we are going from 2 to 1, that is upwards, then we have to subtract because that much pressure is decreasing, which is why we are subtracting. Rho L has come here because we are in the water liquid, right? Rho L or rho W. And H1 because that is the height that we are going from 2 to 1. Right. So we have PA equals to P ATM, that is the atmospheric pressure, plus rho Hg GH2 minus rho L GH1. Manometer is nothing, you just have to write the pressure equations everywhere and solve for the unknown given. Okay, so that concludes our manometer section. I think there are a few questions in the tutorial also, so don't worry, we will be solving all of those as well. Okay, I think that is it for this lecture, and after this we will be solving tutorial 1. It has basic questions based on force equals to pressure upon area. That is literally the only equation required to solve all of them. But I do remember in our quiz they gave some tricky questions, like for example they had a piston and they had given the piston's area as well. So you had to subtract the piston area, this area, from the rest of the area to actually get the correct answer. So they can't do much in it. They're going to try and play tricks on you, and once you've solved questions you will know how to identify the trick that is being played. Alright, see you on the next one.